Welcome back. Today we're going to be taking a look at the where clause, or how we can do stuff to make our results not be quite so crazy. We're going to take a look at how we can actually limit the results of our queries. So what we want to do, most of the time we don't want to actually get all those rows. All the rows we have, it's just not what we want. And using distinct with the select, that's actually not a great way to restrict the number of rows we get, because especially when doing more complex queries, each column we're working with, since they combine together in different ways, they're going to get distinct results automatically. So using distinct won't actually take away the results we get from that. So that's not the great way to actually limit the results. Instead, we have 6 ways we're going to take a look at so we can actually limit the number of results that we have from a query. We're going to take a look at equality, its inverse inequality, similarity, relational comparisons, a range of values, specificity, and compound logic. Let's go ahead and take a look at each of these in turn so we can understand them better. When we're talking about equality, we're looking for either an exact match or an inexact match. So we have either numeric, Boolean, or text values. And we just use a single equal sign, just like we regularly do inside Mathland. And just like in Mathland, the left-hand side just has to be the same value as what's on the right-hand side. Inequality we represent with a not equal sign. And again, the left-hand side is not the same as what's on the right-hand side for that. Now, on Mathland, these are interchangeable. However, because we have a style guide, we're always going to put the column names on the left-hand side and the values we're comparing to it on the right-hand side. Remember that text values, when we do this, we specify text values using single quotes, because the single quotes are how we can identify it's a text value when we're looking at comparison with this. So just as an FYI. So here we have a couple examples of doing equality checks using a select query. So we have select grade point from grade conversion, where max grade is equal to 79. So this is going to get all the grade points that have a max grade of exactly 79. We're going to select all the max grades this time from the same table grade conversion, but this time we're going to select the max grades where the letter grade is equal to B+. And then we'll do select section ID from grade type weight, where the drop lowest value is not equal to Y in single quotes. So when we're doing a comparison with an equality of a string, we use the single quotes on those text values, so varchar, text, etc. When we're using SQL, we use the like command to find similarity values on that. We use that combined with wildcards to make sure we can see if something is close enough to the actual answer. And we place those within, we place what we're comparing inside single quotes so we can actually evaluate that. And the wildcards can be placed anywhere inside those single quotes space. Now this works with both number and varchar, aka text types that we're working with. And we have 2 different wildcards that we're working with. We have the % sign and the underscore. The % sign can be used to represent any number of unspecified symbols. And again, it can be 0, 5, 4, 2, 1, 106. It doesn't matter, it's any number. And you can place that again anywhere inside the set of you can place that anywhere inside the single quote. So you can say, if you want it in the middle of the word and then have some other text after it or whatever, you can place that % sign anywhere. So you can have it so it can look anywhere inside that. And it also includes 0 symbols in between. So it's really helpful. On the other hand, we have the underscore. The underscore wildcard operator only represents exactly 1 symbol. So if you have it in there, it's going to be, oh, the underscore is exactly that value. So I can skip 1 letter and then look at that. You can also concatenate underscores together. So I have 3 underscores in a row, means I'm going to only look at that. I don't care what the first 3 letters are, but I look at what the 4th letter is on that. And so you can do some stuff with that. So here we have a couple demos with that. We have select section number from section, where location is like %4. And so that means all I care about is that the last digit of that location value, that string, is a 4. So it can be 214, 314, 5444. I don't care. Or ABCD4. All great. As long as it ends in a 4, we're happy. On the other hand, we have a select description from course, where course note is like _5 _. And so course note is a course number. And so even though it's working with a number, I still use the string evaluation of single quotes. And so I don't care what the first number is. The second number has to be a 5. And the third number, I don't care either. But it's only 3 numbers long, and those are the values I look at to make those comparisons. My relational operators I use to make relational comparisons. So I have less than or equal to, greater than, and greater than equal to. And you need to remember, though, that they work differently with different types. The biggest thing you need to remember is when you're talking about text or varchar types, that lowercase letters are bigger than uppercase letters, because when we're talking about the ASCII or the Unicode value system, the uppercase letters come first and then the lowercase letters come after. And so when you're doing that comparison, you have to keep that in mind. Numbers work, however, just like normal. Smaller numbers are smaller than smaller numbers. Yeah, I know. That's easy. And dates, however, dates you can work with a less than or a relational operator. When you you can use the relational operators on dates. It does an implicit to-date comparison on a text value. I really don't recommend that you actually do that. You should always use the explicit to-date that to do the comparison on dates. But if you have a valid date string, it will do a comparison on that for you. So using a date comparison. So we have a couple demos right here. We have a select section number from section where capacity is less than or equal to 25. So only small classrooms will work for this. or small sections. We have select section ID from enrollment, where student ID is greater than 254. So I'm only going to get the sections who have student IDs that have numbers greater than 254 inside that. Okay, so I'm going to get numbers with students who are added later. Okay, cool. If I want to get a range of values, I'm going to use the between command with an and operator. So I use between and then two different values, this and that, to compare that. And so the and operator separates those two values. It's inclusive on both sides of that range. So that's a big thing you need to know, that the value itself is inclusive. It can work with number, varchar, and date. And again, if you're using a date value, make sure you have an explicitly properly formatted string, because it does do an implicit toDate call on that. But again, if you're ever working with date values, you should use the proper date extraction operations, because it makes life so much happier. Trust me on this. Here we have a couple range demos. So we have select student ID from section, where section ID is between 83 and 91. So 83, 84, 85, 86, 87, 88, 89, 90, and 91 are all included in that. Then I have select student ID from student, where last name is between Abdu and Avia. And so every single possible combination of starting with A up from Abdu up to and including Avia will be included with that. So if it's A, B, Z, 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 totally cool, but AA, not going to come in there because that's not inside that range. So talking about how you can actually make that last name between those two different values is where that's going to work. We can also do specificity. So we want to do specific values. We use the in command, and then we have a comma separated group of values surrounded by parens to make that happen. Now, when we're working with that, of course the types have to match, and inside the parens though, the order doesn't matter. So you don't have to worry about going a numeric order. You can just, I've got this number, then this number, then this number. That way you just make sure you get all the ones you actually care about, so you can make that happen. So it's a great way to do this. So a specificity demo, we have select first name from instructor, where their last name is in the group of Perez, Romchik, and Zhao. So anyone who has Perez, Romchik, or Zhao as a last name, those first names will be included in that query. Select distinct, so again, we're only going to have unique values from grade, where numeric grade is in 85, 99, and 76. So I'm going to get the grade type codes that have those exact scores. And so that's how that one will work. We can also use compound logic, so we can combine all those different types of restrictions inside that. And so we use parens to group each of our compound things, because when we're using parens, it helps us organize our logic more effectively and also make sure we order them properly. We use and or operators to combine those, and we'll make it so that both have to be true, or of course is either of them are true. Now when we're talking about order of operations, it goes first parens and then top to bottom as you go through that. So this is really important when you're talking about making a compound logic, that you design that appropriately, because otherwise you're going to screw up your logic and you're going to get the wrong answers. Now, as we're doing compound logic, I really bring this up again, that computers are just dumb little boxes of metal and sand. We've enchanted electricity, and so they only do exactly what you say. So if you don't give it the correct logic, it's going to give you the wrong answer. So keep that in mind, especially when you're doing compound logic queries. Here are a couple quick little compound demos. I have select student ID from student, where the last name is between Abdu and Avia, like we had earlier, and the salutation is not equal to Mr. So this will only get ones that don't have Mr. as a salutation. Then we have select description from course, where course no is like _5 _, middle number is 5, or the course number is greater than 200. So I will get a whole bunch of things that don't have a 5 in the middle because it's greater, because their course no is greater than 200, but that still matches. So I expand out those results. So again, make sure you're talking about the logic on that so it matches appropriately, so you can do the comparisons so it'll work appropriately as you go through this. So keep that in mind as you go and make that happen. I just want to make sure this is a nice review where you can limit results. Again, most of the time it's not enough to simply use distinct. So we do our comparisons based on equality, similarity, relational operations, ranges of values, specific values, or compound logic, where I combine and join those different types of logic inside there. I hope this is a helpful review. Cheers, we'll see you next time, and have a great day. Bye-bye.